Hello everybody. Uh, Welcome to the 12th day of base SAS. What we are going to cover is basically around the processing data iteratively, or we can we use a lot of iterations. When I say iterations, it means the repetitive tasks. So the functions or options which are available in SAS when we need to process some data or do some calculation iteratively, then we use these loops or arrays, right? So it depends like where you need to use loops or where you need to use arrays. That depends. But before this, let me just do a recap that what exactly we have covered till now. We have seen that how to create various data sets in SAS, and how to process the data from text file Excel into SAS, then how to filter or use if or where depending on the circumstances or situation in various data sets. Then in last session, if I talk about especially the session 11 which we covered, so we saw that how to create various plots or charts which are available in SAS base. So we saw the working with the pie chart. We saw like how to work with a column or a bar plot or how chart basically, and how to work with the row chart. And then we saw how to create star or various shapes or plots, basically the trending, how to create the trending we just saw in the previous chapter. Now, like when I say that the iterations or the repetitive tasks which we need to do in SAS, and how we are going to cover that today in our session, that will matter. So basically, like when I am going to start that, let me tell you that basically the loops, as in every programming language, you might have seen that the loops are used to process the iterative task, or let us suppose you need to do a calculation, same calculation for n number of things, then you can use loops, right? And array is nothing but the group or the collection of similar kind of things. So that's a generic and common across all the languages. So let's say I'm going to start our day today with the loop, the first episode or the topic which we are going to take, that is looping or do loop process basically, right? So I'm gonna take an example here when okay, let me just show you that example first. So this is the example here. You can see that the code which I have written here, that says that data compound interest, then year is equal to 2010, right? Then amount is equal to whatever amount is given, and then into 1.90, that's a rate. So we are multiplying it with the basic amount. Now the condition which we have just used was for year 2010. Now if I talk about year 2011, what we have done, we have taken the same amount and we are multiplying with the rate. So if you see at the condition which is given for year 2011, then year 2012, and then year 2013, you can see we have repeated the same calculation all across for these 3 years. It is just that the condition for year 2010 is different. But if we talk about the condition given for 2013, 2012 or 2011, that's same all across. And at the end of the later part of the program, the code, we are just printing the data set which is compound underscore interest. So the topic which we are covering right now, like you can see that the repetitive lines which have been used for 2011, 12 and 13, we can use a loop, and we can use these lines once only to process all the data for year 2013, 12 and 11, right? How are we going to do that? You need to concentrate about the syntax which is mentioned here. So you can see that the other way of doing the similar task which was there in the previous slide is that you can write like for year 2010 we have done the same thing because the amount was different, but for year 2011 to 13 we have taken for do year is equal to 2011 to 13, then amount is equal to amount into 1.09, which was the rate we taken for, right? And then output. So like we had the three sets of code. We have replaced that with the one set of the code by using this loop. So where there are many repetition, the do loop becomes more efficient and it does that the same thing. It basically it runs thrice as per the code which we have used. But yes, while it comes to writing the program, that's very efficient and we need to write less line of the program, less number of the lines in a program. Now, like as we have taken in one example of this do loop here, right? Similarly, as in other languages, it happens or the same with the SAS. So various forms of iterative do loops, right? So there are several forms of there are several forms of do loop that we can execute or that can execute the statements between do and end statements repetitively. So when I say between do and end, it means all the loops which we are going to look today will start from do keyword and they end with end keyword, right? So you can see here that the first one which is given here, that do index variable is equal to start to stop. Start to stop is nothing but the lower limit to the upper limit. This is what you need to give. And by increment basically you need to specify that how much increments you want. Do you want it to increase by one, or do you want to increase it by like 2, 3, or a number, whatever you want, or whatever you will specify there. Then whatever action you want to be taken, that need to be written between the do statement and end statement. So all the key point or the action which whatever you will mention between do keyword and end keyword, that will be executed n number of time, or the number of time by which you will run that loop. Or the other way could be like you can write do index variable, then item 1, item 2, item n. So this is the other way of running a loop where you need to run the loop n number of times. So you need to mention those numbers and it will run for each of them. Okay, and here is the place where we can use array. As I said, that array is nothing but the collection of similar kind of objects. So if you have an array, you can just write do index variable is equal to your array name, and it will run for all of those items, whatever are collected or mentioned in that array. And then again, it's same that what you're going to write is whatever action you want to be taken, that need to be written between do and end statement. All right, let's go ahead and talk about the next slide which we have. So basically the next slide is talks about the various components of a loop, or when I say loop, it means let's say we are using the do loop, then what all keywords or what are the attributes or the arguments which we need to use, or they need to be either compulsory or they are optional while writing a do loop. So the syntax would be simple as do, then index variable, and then start to stop. So the lower limit or the lower bound to the upper bound, and by increment. So these are the rules for start or stop the increment, that they must be numbers or expression that yield numbers, right? Then they are established before the loop, and if omitted, increment defaults to 1, right? So if you, let us suppose you are not mentioning anything by increment, then it would be default to 1. Like let us suppose you want to run a loop from 1 to 10 and you have not mentioned the increment, so automatically it will increase increase by 1 every time. So let's say like first time it ran for 1, then the second time it will run for 2. But if you mention anything in the increment field, then it will get incremented by that particular number, whatever you will mention. Then, as I already talked about what is start and stop. So start specifies the initial value of the index variable, whereas stop specifies the number value for the index variable or the upper bound till what you want that code to be run or the program to be executed. Now, like similarly, we have some other things as well to talk about the do statement and what are those that we can see into this, like the index variable. Basically, the index variable which we just mentioned here after just the do keyword. So that's the index variable is written to the output data set by default, and or like at the termination of the loop, the value of index variable is 1, increment beyond the stop value. When increment is positive, the start must be lower bound and stop, if represent, must be the upper bound for the loop. When increment is negative, start must be the upper bound and stop, if present, must be the lower bound of the loop. So this is basically understood, like if you want an increment to be negative, then definitely your start should be always greater than the end point, right? So that is why it would be negative from high to low. But in case your increment is positive, so positive will always increase. It means your start should be lower than the stop, so so that it can get incremented by the number or the increment whatever you specify. All right. And the next thing would be or the specific point which we can discuss, that the changes to the values or stop or increment made within the do loop do not affect the number of iterations. So I will repeat, changes to the values of stop or increment made within the do loop do not affect the number of iterations. What I mean is, suppose that if you are running a loop and in between that you are changing any of these values, so that's not going to affect the loop, because whenever the loop gets started, the value set every time, so gets sets every time, right? So it will run for the original or specific values which have been mentioned, and the number of iterations will depend on the values of start and stop with the incremented values. Then further, or the next thing to talk about would be that modifying the value of index variable affects the number of iteration, and that might cause infinite looping or early loop termination. So index variable is basically the condition that will definitely affect, because on that value you are going to run your loops, right? Okay, so that was all theory about about a loop. Now let's see. Okay, like how we had a sequence of values for iterative do loop, we can also have an item list for values of index variables in the do loop. So we can have lower bound or upper bound. Similarly, as I talked about the array concept, so we can have the list of variables as well, and the loop will run for each variable in that. So the do loop is executed once for each item in the list, and the list must be comma separated, right? So we'll talk more about this in the later part of this chapter or session today, because we are going to cover arrays and wherein we'll talk about the list and or how we can define an array so that we do not need to give anything manually in the loop. All right, let's move to the next slide that says conditional iterative processing. So you can use do while or do until. So as we were talking about, the do loop. So we have the two types of do loop. One is do while and another is do until, right? So these statements, do while or do until, okay, statements to stop the loop when a condition is met rather than when a loop executed a specific number of times. Okay, so you can use do while. All right. So, the do while or do until statements to stop the loop when a condition is met rather when the loop executed a specific number of times, right? So, I mean, it could depend that how you want to run your loop. So the best way would be so that you can specify the lower bound and upper bound and execute your loop between those bounds only, those limits only. If you're not going to mention those, those limits or the lower bound or the upper bound, your loop is gonna run for n number of times irrespective of the condition whether it was met or not, right? So it's always a better option to stop your loop as soon as it reaches to the lower or upper bound. Okay, so like the condition is also given or it's a warning that to avoid infinite loops, be sure that the specific condition will be met. All right, now let's move to the next slide and we talk more about the do while statement or the do while loop. So do while statement executes statements in a do loop repetitively while a condition is true. Okay, so by the time the condition is true, the loop will keep running. So and the general form of do while loop would be do while, then your expression, the condition which is gonna be true, then the statement which you want to be executed till or until the condition is true, and then end. The value of expression is evaluated at the top of the loop. The statement in the loop never executes if the condition is initially false, right? So as I said, the loop will run until your condition is true or while your condition is true basically, right? So as soon as you will get or your condition becomes false, loop will stop then and then. And that is why, like, if your initial expression is false, your loop will never run. Then do until statement. Do until statement executes statements in a do loop repetitively until a condition is true, right? So like if I say the differences between both, okay, so do while loop keeps running by the time condition remains true, whereas do until stops as soon as conditions become true. Okay, so for all false situations, do until keeps running while do while runs for all the true conditions, right? It's a simple difference between both. And then the general form of the do until loop would be do until your expression, statement, and then end. The value of expression is evaluated at the bottom of the loop. Basically, as soon as it captures that the condition is true, it will stop there and then. Okay, so the statements in the loop are executed at least once. So whether the condition is true or the false, it will at least execute once, and as soon as it finds that the condition was true, it will stop. It won't run for the next iteration. Do while will not run if the condition is false initially. Although the condition is placed at the top of the loop, it's evaluated at the bottom of the loop. So that's the difference between do while or do until. Now iterative do loop with the conditional clause. So you can combine do while or do until statements with the iterative do statement. General form of iterative do loop with the condition clause that's given as in syntax here, that do index variable is equal to start to stop, right? The increment you will mention while or until expression statement in the loop. This is one method of avoiding an infinite loop in the do while or do until statement, because those conditions may run infinitely. Okay, nested do loops. Nested do loops are nothing but the loop inside a loop. As similarly we write nested if or nested functions. So basically inside a function you write another function. So that is what the meaning of nested is. So you can see see in the example or the syntax which is given here, that the do index variable 1 is equal to start 1 to stop 1 by increment, and inside of that we have another do statement that is again index variable 2 and start to the stop 2, and then you have writing your statements, and at the end you have ended it twice for both the loops. Be sure to use different index variable for each loop. So we can take it like suppose that you want to get the data for 10 years, right? So what will happen, like you first of all, for every year you will have to run it for all the months, and then the same method will repeat for all the years, right? So it means for all the years you will run it for all the months. So you can run two loops here, one for month and one for year. So for monthly loop will run for 12 times, and similarly yearly loop will run for all the number of years for which you want the data. So be sure to use different index variables for each loop. Each do statement must have a corresponding end statement, and the inner loop executes completely for the each iterations of the outer loop, right? So we have talked about all the kind of loops which are available in SAS. So those are not much different than other languages. Those are common. But yes, the best thing would be to know or to understand that how to implement these loops into your program to make your program more effective or efficient, right? So here we have an example of code that generates the compound interest monthly for the principal of 10,000 for 2 years, right? So the code also allows us to change the rate of interest, the principal, as well as the number of years. So you can see here the code which is given, that the data compound, this is the name of data, retain balance 10,000. I'll talk about retain later. Before that, let's talk about this do year 2011 to 2012. So that is the range of years. 2000N would be the start. 2002 would be, I would say stop, the lower bound and the upper bound. Similarly for the inside loop. Okay, we have a good example here. I would like to take a moment and tell you that how basically this is going to run. Okay, so let me just take this code out here. All right, so let me modify this. First of all, Okay, let's see. First of all, I'm going to comment this, and then I will take only one loop. Okay, so you can see here, I will save it like, okay, it would be saved into compound, then work library. Let's say I'm running it, and now the output would be shown here. So you can see I have got two entries in year column, that's year 2001 and then year 2002, but in case of balances I have missing value, right? I don't have any value. Why? Because if you look at the code which I used here, the balance, I have not initialized the balance anywhere, right? So in order to initialize that, you need to write a retain statement. And if I write that retain balance is equal to 10,000, and if I run this once again, let's see that what happens. Now you can see that for, we have a balance and we have year as well, right? For year 2001, for this, so you can look at the code. I have just simply run it for 2000. Let's say I'm going to run it for 5. So it will start from this 2001 until run 2005, and balance, it will initialize balance from 10,000, and then it will do this calculation every time and provide the output. I'm running it once again. Now you can see that I will have data for 2001, then 2002, 2003, 2004, and 5. So this is the one side of the loop, or the single loop, which we have run. Now similarly, the case could be that if I use the inner loop as well. When I say inner loop, so I need to use this. I know that there are 12 months in a year, so I will just write like this. Okay, and if I'm going to run it, you will see that it will run for, first of all, it will run for 2000 year, all the months of 2001, then for all the months of 2000, 2, then 2003, then 2004, then 2005, and the amount or the calculation which I used, that is done on the monthly basis. So for each month, the amount will increase, or it would be increased, or it will change as per the calculation which I have given there. So this is a loop inside of a loop, and it's very useful. It has this is used at many cases. So had it been a case that it's, let's say it's a week, so I will change it to 1 to 7, right? So let's say it changes every day of the week, then you will see that I will get 7 days for 2001, then 7 days for 2002, then 7 days for 2003. So this is how the data changes every time the loop changes. So this is the inner loop, and this is the outer loop, right? So the outer loop runs for each condition, or the each value which it gets into the inner loop, right? So this is the beauty of using nested loops in your program, or in your SAS program. Let me save this data set, somewhere. So I'm going to do the same thing what I have been doing multiple times. What I mean is, I'll be giving a reference to Satya library now, and I can say libname Satya, Here we go. And the data would have been saved into Satya library. If you look at compound, here we go. Right now, let's move to the next slide, which we have. Okay, so we till now we have just talked about the do loop, which we have been using. Now, before I go to arrays, let me talk about the sum statement, wherein or the total, which we use very frequently in SAS. So let me just create a database wherein I can show you that how we are going to use sum and the importance of retain the keyword which I was talking about. So let me just write a program, and then I'll talk about that. So just give me a moment. Okay, so I'm just writing a program here that says data is revenue. Then I have a day and a day variable, and it's the informant which I'm taking it as length would be 3. Then I'm taking revenue. Let's say the other variable is revenue, and I'm defining its informant as $6, and I have another column says total, and let's say this calculation would be total is equal to total plus revenue. Now look at the code which I'm writing. It would be very important for you to know exactly what this code is doing, right? Now I'm giving the formats for revenue and total. So let's say revenue and total for both. I'm giving a format of $8, right? Now let's say I need to give the data for these. So this is the other way of defining your data or creating a data set. So you can include this as your mini project. Okay, so as I initially said, the informant of revenue is dollar, so I have given it as this. Then Tuesday dollar, here we go. Then for Wednesday, let's say I have taken a missing value. Then Thursday, let's say I have $2,000. Then Friday I have $3,000, and at the end of it I will run my statement. Okay, so let's say this is the data which I have I have written a program here. So you can see that I have defined two variables, day and revenue, and I want to find out the total. You can see here that I want to find out the total with help of revenue for each day, whereas at one place I'm getting revenue as missing. So now it could be a challenge, because you know that missing is same as null as in SQL. So if you have anything as missing or null in SQL, so whatever mathematical operation you do with that number, that turns into the same. So if it is missing, it will be turned into missing. So if I add missing plus 1, it would be missing. So let us suppose if I'm going to find out the total of all these, so missing is one of those values, and I'll be getting missing for the complete result set. So let me just print it out, and I will see that exactly what we are going to get. So proc print data is equal to Satya dot revenue, and then I would say run. Okay, let's see. I'm just running this complete program. You will see that I have got day and revenue, but I don't have total anywhere. It's a missing all across. I had a missing value in Wednesday, but we are getting total missing all across, right? So this is a challenge, and that's wrong. So basically, let me tell you that why it happens. Total is nothing but the sum, right? So what basically happens that this program makes use of sum statement. As I'm trying to find out the total, it's using the sum statement, and this is seemingly simple statement is extremely this is very extremely useful, right? You may also find that in majority of the SAS programs, uh, they don't fully appreciate that how to use it, because like you have just seen that I've used it in a simple way, but I have got the missing values, right? So there are two primary uses of a sum statement. One is the accumulate total, such as the month to date total, or the other way is to create a counter, right? A variable that is incremented by a fixed amount of each iteration of the data step. So let us suppose that you have a data set with one observation for each day, as we have taken here. Now we want to create a cumulative sum. So this total will not be nothing but a cumulative sum, but it's not working here, right? Why it's not working here? So for that, you always remember that the variable read from the raw data or created by assignment statements are initialized to a missing value, right? So if you look at the program once again, we have not initialized this total, right? So if we have not initialized, so automatically it will be initialized to a missing value. And that is why, as I said, that if you add anything into a missing value, it would be a missing value again, right? So in order to avoid that, you need to initialize it, and for that you can use retain statement, right? So if I write a retain statement at the beginning, okay, so I can write like this. Just after it I can write retain, and I would say total is equal to 0, or I can retain it to anything. Alright, now if I run the same program, you will find it out that you are going to get a result in the total field. Here we go. So you can see that I have total for Monday and Tuesday, but again a strange thing, we don't have result Wednesday onwards, and you may know that why, because for Wednesday we had a missing value. So as soon as the missing value got added uh, to the total amount which we had, it turned into a missing value. So again, this is also not correct. We know that this is not correct. So you need to find out a way how to implement it in such a way so that you get a value every time, right? Everything here works fine, but the program encounters a missing value for the revenue after the Wednesday, right? This sets total to a missing value where it remains for the rest of the data step. So you can fix this by adding a statement to the test value to revenue before you attempt to add to the cumulative totals. And what basically you need to add here is, you just need to add if not missing revenue, then total is equal to revenue. So what you need to write here is like if not missing what revenue. If revenue is not missing, then total is equal to total plus revenue, and rest of the things will remain same. Now if you will run it, it will encounter the missing value in revenue, so it will ignore that. Or for others, it will do total is equal to total plus revenue, where it will retain the total value as 0. So you can see it now that I have got the values or the cumulative sum in total column for all the fields, and whereas the missing value for Wednesday is still the same. Alright, so this is how we have just seen that how we can overcome this challenge. What here comes. So the main point or the things which you can take care of, that the plus sign or the no equal sign is in there in the statement, right? Then the statement what identifies this as a sum statement to SAS. That statement does the following: variable is retained. So I have used this. This is the first thing where variable is being retained. Then I have initialized this by 0 by giving it. So for the total, it starts from the 0, not from the missing. And because of this, like the condition which I have used, if not missing revenue, then this total is equal to total plus revenue. So that indicates that missing values will be ignored. All right. So I guess we have talked about the various loops, and then we talked about the retain keyword, which is very important while writing some iterative codes. So let's move to the next slide, which we had the arrays. So before we go ahead, let's talk about that what array is. So I have been talking from the beginning that what array is. Basically, array is nothing but the collection of similar kind of objects, right? When I say similar kind of objects, so if I say Monday, Tuesday, Friday, so it is a collection of number days, right? So it is, if I put Monday, Tuesday, Thursday, Friday, Wednesday in a bucket, it would be called as array, and where the object is the number of days, right? So number of days is also an array, and this is exactly what we are going to Okay, so as I said, let's talk about the array. So what is an array? SAS arrays are collection of elements, usually SAS variables, right? When I say variable, basically the columns in case of SAS. So usually SAS variables that allow you to write SAS statements referencing this group of variables. But the thing which need to be taken care here is that SAS arrays are different from the arrays in many other programming languages. They are not hold values, and they allow you to refer to a collection of SAS variable in a convenient manner. So this is much easier to understand what an array is by a few simple examples, right? So the thing again I would repeat that the array is itself not stored with the data set. It is defined only for the duration of data step. So you can give the array any name as long as it does not match any of the variable name in your data set or any SAS keywords. The rule for naming arrays are the SAS naming conventions. Note, a SAS array is not a variable, right? So these are the things which you need to take care of. Now, we use arrays to simplify programs that do the following: perform repetitive calculations, right? Create many variables with the same attributes, read data, compare variables, and then perform table lookups. Now, how to reference a variable element or the array element, that we are going to see. That each element is identified as subscript that represents its position in the array. When you use an array reference, the corresponding value is substituted for the reference, right? So before I talk about a more technicality of the array, let's see an example that what an array could be. Okay, I go here. All right, so just look at this, uh, the component of SAS statement or the array statement. That array statement is a compile time statement, right? That is a thing to taken care of it, or you should know that array statement is a compile time statement that defines the element in an array, right? So elements are created if they do not already exist in PDB. Now the array name, how you define an array, that array and then array name, subscript, length, and then the elements of array. So it means you give the format, whether it is a numeric or if it is a character, and then the elements. Subscript basically the number of elements. Dollar sign indicates the character element, and length, as obvious, like if it is character then you need to specify the length, and then the name of elements. So this is how you define an array. Then some like more detail about the array statement, and that is that array name. It specifies the name of an array. Then subscript describes the number and the arrangement of element in an array by using an asterisk, a number, numbers represented by comma for multidimensional array, or a range of numbers, or the subscript which is enclosed in the braces. We can also use curly bracket or the square brackets to enclose the subscript. Then we have a dollar sign that indicates that element in an array are character elements. The dollar sign is not necessary if element in the array were previously defined as character element. Then the length specifies the length of element in an array that were not previously assigned a length. And then array element, the name of element that make up the array. Array elements can be listed in any order. Okay, then we have the following array statements. Defined an array called captain to access the 5 variable language, English, math, science and social. Array captain 5, right? So that shows, this 5 shows that there are 5 members in the array, and what those members are, that is language, English, math, science and social. So these 5 variable language, English, maths, language, science and social can now be referenced via array named captain within an appropriate subscript. So if I say captain 1, that would be language. If I say captain 2, that would be English. If I say captain 3, that's math. Okay. An alternate syntax uses an asterisk instead of a subscript. SAS determines the subscript by counting the variables in element list. The element list must include that array captain then asterisk, right? Language, and this is the way how we define this array. Now you can also use a special SAS name list to reference variables that were previously defined in the same data step. Array captain asterisk science is social. Okay. Now variables that are element of an array do not need the following. They need not to have a similar or related numbered names. They need not to be stored subsequently. They need not to be adjacent. Okay. So if whether they are sequential or not, but if they are assigned into an array, we know that those are referenced because we can use them by giving reference of that particular array. For instance, in PDV we have the following variables in this order: that employee ID, name, date of birth, address, hire date, salary, designation, experience. We can use the following statements to define the array. Array stone, employee ID, experience and salary. And how those are going to be defined, that is stone 1 would be employee ID, stone 2 would be experience, stone 3 would be salary, right? Though irrespective of that order, though that is not the order in PDV, they would be in any order, right? So that is not a big deal that how they are going to be referenced, but if you reference it, automatically it will count, or the counter will run for all the objects or all the members of that array. Dim function. So dim function is basically the function returns the number of element of an array. This value is often used as the stop value to the do loop. So you must remember, while talking about the loops, I talk about the lower bound and then upper bound. So this dim function is basically gives the upper bound for an array. So the general form of dim function would be the number of elements is equal to dim and then array name. So the h-bound function returns the upper bound of the array. L-bound returns the lower bound of the array. Okay. Now example, do I is equal to L-bound items to h-bound items statements. So we have just seen that how to find out the lower bound or the upper bound out of an array. How to do that? L-bound is lower bound, h-bound is the higher bound or the upper bound. And here is the array name is name items. Okay, now we have an example here that you can see that data medals is equal to set files dot Hyundai underscore sales, then retain price, and that price is given as 0, array awards asterisk, then Jan to December, right? So you can see that this array contains all the members of month. Now do I is equal to 1 to dim awards. Dim will give the number of elements. So 1 to all the numbers or all the members, the number of members contained in awards. Then if I is equal to 1, then price is equal to 0. If award is I is greater than 80, then price is equal to price plus 1 and keep store price. So this is how this program is going to run. Similarly, the another program which is given here, that data is equal to class, length is the one variable, then sex, then we have salutor, that is the third variable. Now we have done SAS help dot class. Okay, so let's just find it out whether we have this data set. If we have it, we can use this code and I can show you how basically this program is gonna work. So let's see SAS help dot class. SAS help, and we have class. Okay. Okay, let me just print the basic data step, which was SAS help.class. Let's see what kind of data it has. So you can see it has name, sex, age, weight, and height. Right now, the program which we have written is that we want array welcome to name and sex. So these are two member they have taken, name and sex. Then if 2 is equal to m, then slaughter. Okay, so if sex is equal to male, then just slaughter, and we are concatenating Mr. And if it is else, Mrs. So what we have done, we have ran this loop all across the values. Depending on the sex, we have added Mrs. or a Mr. to the name or the slaughter. Right? Slaughter is nothing but the concatenation of Mrs. or Mr. Then welcome one is nothing but the first array, right? So if you look at this is exactly what it is doing. If it was M, then Mr. If it is F, then Mrs. So it has, I mean, we have ran this loop. You can see this array, and then we have run the loop in order to do this concatenation into the code. So it was a good example for us, right? So like we have just covered arrays, and then we saw that how these various loops are working. But let me just tell you a few more an important thing. The same thing which we talked about in case of concatenation, sorry, in case of loops, the retain keyword. So the same problem can come here. So we need to, while working with this, we need to take care of that how we are going to treat that. With this, you can create an array that only has the elements and no variables, right? It sounds strange, but you can, right? So the element of a temporary array are a great place to store values or perform table lookups. If you want, you can assign the array element initial value when you create the temporary array. Alternatively, you can load values into temporary array in the data step. Either way, the value in the temporary array are automatically retained. That is, they are not set to a missing value. Okay, when the data step iterates, it happens in case of temporary arrays. So temporary arrays are a very useful place to store values that you need during the execution of data step. So let's take an example and let's see that how we are going to see that how to use the temporary arrays. I'll take an example, right? So let's go back to the SAS window, and I'm going to write another program. Let's say data right. I've taken one array called answer, and the data type I'm giving it as character of one length, and it has 10 members. Then another array which I'm taking, let's say key, it also has 10 members, and the length is 1 and the character type, and let's say we take it as temporary. Okay, if it is temporary, the values which I'm going to assign to it are like A, B, C, D, E, F, G, H, I. Okay, let's take the values from E. Then what I'm going to do is then E again. Let's consider a type of variable like this, and just wait a minute. Let's see that what it's gonna create for you. All right, now input ID. What I'm doing is answer 1, 2, answer 10. This is the complete range, and I have already said that that would be of and which says that this is character type. Here we go. Then I'm going to take a variable called raw score, and I will give it a value called 0. So I'm initializing it with 0. Then starting the do loop, let's say question is equal to 1 to 10. Then raw score plus key questions equal to answer All right. So you can look at the program. This is the big program which we have written. You can simply say that these are the 10 options given to various answers, and I have taken two loops basically. So two arrays. One is for all the correct answer, and another is all the available options. This is what the temporary is. Temporary means one can select any of these, and then he can then I'm going to run this my loop, which runs for all the questions, 10 questions, and it will select any of those answers. So this is basically, you can see in the variable 2, I have all the things or all the available options, and it will select one of those. So let's see that how my loop runs for it. Okay. So I have found out some error in the syntax. Let me just look at this. Alright, so what we have just done, we have just changed it and just remove the bracket, and we have just found out that this code is running. Now let me just run it once again for you so that you can see the kind of output it's creating. You can see it has ID, then it has scores and the total percentage what it is getting. So you can see that out of these arrays only I have created this result, right? So basically this is one of the examples or the better examples which we have given here, but apart from this you can use the temporary array for the multiple in multiple scenarios. This program uses a temporary array, right? The key to hold these answers or the options quiz questions. The keyword temporary tells SAS that this is a temporary array, and the 10 values in parentheses are initial values for each of the elements in this array. It is important to remember that there are no corresponding variables key 1, key 2, or whatever values which we have used in the data step. Also, because elements of temporary arrays are retained. The temporary means they are already initialized. So this is the beauty, or this is the the benefit of initializing them in the beginning. Then also, because elements in a temporary arrays are retained, the 10 answers key values are available throughout the data step for scoring each of the student. The scoring is done in the do loop which we have used here from question 1 to 10. So it is a trick to use to do the scoring. A logical comparison is performed between the student answer and the corresponding answer key. If they match, the logical comparison returns 1 and this is added to the row score. And if not, the result is 0 and the row score is not incremented. Here is the listing what we have just seen out of that, right? So for 1, 2, 3, the score was 7 and the percentage is 70. Similarly, the percentage is increasing against the each answer. So this is how the arrays or multi-dimensional arrays can be used. The temporary array can be used while doing a lot of data modification or the calculation which we have. And like in advanced SAS programming, these are the most important topics which one should use in order to provide a better justification or provide a better analysis in case of the SAS data sets. So we have just covered looping system, how we loop, how we do the iterative processes in SAS, and then how to create arrays, how to create the collection of the similar kind of objects. And we saw that the type of arrays as well, like the temporary array or multi-dimensional array, we have just seen all these things. So I guess we have just covered these two topics, which basically comes into the advanced SAS, but it would be good, and they will give a good startup to you. So just let me know if you have any question, or just drop me an email regarding these questions, and that's all for today. Thank you so much for joining this session. Thank you so much. Have a nice time.